In the last video, we read the status of an I/O port to turn on an LED when we pressed a switch. If we want to make this closer to a real-world application, and the type of application where millions and millions of AVRs are used in a very simple and glamorous type way, when you have a switch and the system is off or in a very, very low power mode, and you've got an AVR just monitoring for a pin change interrupt, to which it then, when the button is pressed, it wakes the system up. So this kind of a board controller is quite common, and it's based on a pin change interrupt, and we won't cover the sleep modes in this video, but we will start looking at how to use interrupts. Okay, so we have our code. We're going to actually keep the functionality of the project exactly the same, except we want to have this logic about checking if the pin is being pressed in an interrupt service routine instead. So let's go to the data sheet and have a look at first at port B. So because what we're actually wanting to do is understand a little bit more the port that we have, and it's a bidirectional I/O port with pull-up resistors. Various special features are elaborated in alternate functions of port B. So let's go there. And first of all, we can see port B7 is associated with pin change interrupt 7. So let's go to the end of the data sheet and we'll look here for the register summary and search for this pin change interrupt 7. And here we can see that this is part of a pin change mask. Okay, so let's see where that is. So if we look under interrupts in the data sheet and then under external interrupts, because a pin change interrupt is an external interrupt, we can see this pin change mask register. Pin change mask register 0, and here we have our pin change interrupt 7. So each bit selects whether a pin change interrupt is enabled on the corresponding I/O pin, and the pin change interrupt enable bit in the pin change is set. So what we want to do is right here, so we're going to set this bit for pin change interrupt 7, and the other thing which it asks us to do is if pin change interrupt enable in 0 in pin change interrupt control register. So where's the pin change interrupt control register? And that also needs to be enabled. Okay, but when we read this here, it says, and the I bit in the status register. So a status register is a very, very important register in the AVR. So let's have a look at from the beginning of the data sheet for status register. And here we can see that the I bit is the global interrupt enable, and it must be set for interrupts to be enabled, and can be set and cleared with this SEI say instruction. Okay, so when we were working with delays, we got a lot of help from AVR LibC. So let's go back to LibC and see what they have for us on interrupts. So going to the library reference of AVR LibC, let's look for interrupt, and we can see AVR/interrupt.h. So that's a clue in the include file that we need to add. So we can see that in order to use any of this functionality, we need to use include AVR/interrupt.h. So let's start with that straight away. So adding the include AVR interrupt. Okay, so we've added the prerequisite include and define say enables interrupts by setting the global interrupt mask. So we can call this function now enables interrupts by setting the global interrupt mask. We will find in the data sheet what this vector name is called. So if we go to the interrupts and then we go to the interrupt vectors in the Mega 328, we can find that we are using pin change interrupt request, and that's the source. So let's look in libc for this. And here we have interrupt service routine pin change interrupt 0 vector. So that is what we're going to use. So we set up an interrupt service routine pin change interrupt 0 vector. We can now move the logic of our program to this interrupt vector. And let's just clean this up a little bit more as well. With the macro switch pressed. And our code is now self-documenting. And okay, so remember the functionality is exactly the same that we had before. So to test that this is working, I'm going to set, well, I'm going to start debugging, and I'm going to set a breakpoint on in the interrupt service routine. So if we run the code, it will not hit this breakpoint until we push the button and our interrupt service routine is hit. And if we now clear the breakpoint and run, we have the same functionality that we had before.